Okay, hello Math 223 students. I've created several YouTube videos going along with the course content. I'm going to begin with chapter 7 in the book. We're going to do chapters 7, 8, 10, and 11. And the tests will be from 7.1 to 7.5 is test 1, and then 7.8 to 8.3 is test 2. And then 10.1 through 10.4 is test 3, and then 11.1 through 11.10 is test 4. Now, to move forward in calculus and learn new ideas, it's absolutely critical to understand the basics coming from Calc 1. Limits, derivatives, and integration, especially substitution. We're going to see that a lot. The following problems are from Calc 1. And they're good to know for Calc 2. Okay, so the book right at the beginning of chapter 7 gives kind of a summary of integrals to know at this point. So these are the integrals to know at this point. Okay, and I've got just some review type questions coming from Calc 1 that I'd like you to look at. You're going to evaluate integrals and then evaluate the limit if it exists. I've also got the solutions to those problems as well, and I'll attach those on the Canvas page for you. And so here's the solutions to all that. Okay, and so we're going to start with chapter 7, like I said, and now that we've seen the basic methods for integration, including substitution, we want to build on that and look for other techniques for integration. Okay, so chapter 7 is all about techniques for integration. By the way, like 90% of Calc 2 is going to be all integration problems. Okay, integration is very, very important in calculus. So in 7.1, we'll talk about integration by parts. Now, here's the product rule. Okay, so if I'm differentiating a product, f of x times g of x, I take the first times the derivative of the second plus the second times the derivative of the first. Okay, and I'm going to use this equation here, and I'm going to integrate both sides of this. Also, I'm going to flip both sides. Okay, when I integrate a derivative, that's the operation that kind of undoes the derivative there. So I'm going to get f of x times g of x on the right. Okay, and then on the left, I'm integrating, this side here. So I've got to, and when I integrate a sum, I can split up the integral if I want. Okay. Now the next thing is I'm going to make a u substitution on this first integral. So if I let u be f of x, then the derivative of u with respect to x is f prime of x. Okay. And then v is g of x. The derivative of v with respect to x is g prime of x. Okay. By the way, that's Leibniz notation for derivatives. You learn about that in Calc 1. Okay. They mean the same thing. So from that, if I then substitute this, okay, u is f of x, okay, and then times g prime of x dx. Okay, well, g prime of x, this dv dx, the dx's would cancel, going to leave me with dv, and then plus the integral for g of x, that's what I'm calling v, times f prime of x is the same as du dx, right? So the dx's will cancel, and we have du equals u is f of x and v is g of x. Okay. Now from that, if I then subtract this integral from both sides, then the integral for u dv is where I take uv minus the integral for v du. Okay, and this is basically the formula that you'll need to know in this section. That's integration by parts. okay? So I've got a bunch of examples here. And now I try to select problems that are different from ones that are in the book. So if you want more examples, look at the ones that are in the book, okay? But the first one, okay, so if I want to integrate x times sine x dx, so a lot of these problems are going to be like the only way that you're going to do them is to use integration by parts. There's no other way to do the problem. And so I've got to come up with a u term and a dv term, okay? If I let u be x in this guy, the derivative is 1, and make sure I've got the notation good there. So du is dx. Dv would be the leftover part of what's inside the integral, which is sine x dx. And v would be the antiderivative of sine x. So the antiderivative would be negative cosine of x. Okay, because if I differentiate cosine of x, I get negative sine x dx, or, the opposite of a negative is a positive, okay? So then, now, what if I were to switch these, okay? Like, what if I were to let u be sine x and dv be x dx? Well, if u is sine x, then du is cosine of x dx, right? And dv is x dx. V would be 1/2 x squared. That's not making this this new integral here be any easier than what it could be, okay? Because I've now increased the power of x, so that I got x squared times cosine of x. Okay, that's not really any different from what I had there. Okay, so the whole idea with integration by parts is to create a new integral that you can usually get your hands on. Okay, so I'm using this formula here, u times v, x times negative cosine x, and then minus the integral for v du. So minus a negative cosine x dx, minus a negative means plus, the integral for cosine of x dx. Okay, the antiderivative of cosine of x is sine x. Okay, so my answer would be negative x cosine x plus sine x, and then plus a constant. So whenever I have an indefinite integral, one with no bounds on it, I need to make sure that I have the plus c at the end. If I don't have that, I'm getting points marked off, okay? Also, make sure that your notation is good. Make sure that you're remembering your dx's, your dt's, whatever it is, okay? The variable of integration, that's important, okay? And, one nice thing about integrating is that I can always check my answer to see if I got the right answer, right? So I can take a derivative and I should get back to the integrand there. So if I just quick check this, let's see, the derivative of negative x cosine x, well, the first is negative x times the derivative of the second. Derivative of cosine x is negative sine x, so negative x times negative sine x, that'd be x sine x. And then plus the second is cosine x times the derivative of the first, that's negative 1, so minus cosine x. And then plus the derivative of sine x is cosine x. Okay, I got negative cosine x plus cosine x, that's 0. And then the derivative of a constant is always 0. So my answer would be x sine x, which is exactly what I had there in the integral. Okay, I encourage you to check your answers. Especially if you're unsure. That's one nice thing about integrating is that you can always know if you have the right answer. Okay, just take a derivative of what you think is the answer, and you should get back to the integrand. Okay, if we try another one here. So if I integrate x times e to the x dx, now usually whenever you have x times a function, like we had here, u is going to be x, and dv is going to be the rest of it, okay, usually. Not always, though. So if I were to let u be x here, and dv be e to the x dx, the leftover part there, then du is dx, and v, so the antiderivative of e to the x is itself e to the x. And again, I would not want to have these flipped, because if I were to let u be e to the x and dv be x dx, well, du is e to the x dx, and v would be 1/2 x squared. Okay, that doesn't make my integral be any easier than what it could be. Okay, because I'd have 1/2 x times x squared e to the x inside the new integral. Okay, so again, when you use integration by parts, like the idea is to get an integral that's going to be easier than what it originally was, and usually you can go with the answer then at that point. Okay, now sometimes you'll need an integration by parts, twice or 3 times. Okay, so keep that in mind also. So using this formula here, u times v, I got x times e to the x minus the integral for v du. So minus the integral for e to the x dx. The antiderivative of e to the x is itself e to the x. Okay, and this is an indefinite integral, so I need a plus c at the end. Okay, now I've got a note here. Don't get integration by parts confused with a u substitution. These are not the same thing at all. Okay, a u substitution is where you're going to get a brand new integral involving u. Well, I don't have anything involving u in these integrals here. Okay, so it's completely different method for integrating. Okay. All right, we'll go ahead and stop right there, and I'll pick up with this integral then in the next one.